Hello, I'm Fatih, and I want to share an example of using Zig with WebAssembly and passing strings between Zig and the host language, in this case Java, but it will work the same with other languages like JavaScript. And there's also passing struct pointers to the host language, so you can reuse them. Uh, I will add the link to the description. Here we have Zig and Java folders. So to create the WebAssembly bytecode, you can use any of these. And yeah, there's a difference. But this build lib and build exe. There were some discussions on Zig GitHub issues, but both of them work. Maybe they will change it in the future. So it's a moving target. You can check if this doesn't work. And then you can run the Java example. I reduced the version to Java 8 so everyone can use it, and it will basically print the result. So what does it do? The important part is the Zig, and we have WebAssembly Zig here. And yeah, special thanks to Travis in Zig Discord. Thank you. And you can find his GitHub. I made a mistake, and his questions and links made me realize what was going on. So we use general purpose allocator. This was also my another mistake. I used a standard heap page allocator, but yeah, when you make many allocations, uh, it will hit WebAssembly memory limit. But many examples use that. And I was changing a lot of stuff to make it work. Another issue is when you use, I think, debug in the debug print in your code, uh, it gives an error about file descriptions. So when you put it this way, it doesn't give that error and you can compile. Okay, so this is allocate function, which we will export to host language, Java in our case, and yeah, you can find different variations. You can panic or return zero, stuff like that. And in returning pointers, you can also use like usize or u32, for example. But uh, when something works in WebAssembly, like you want it to work in Zig also. So that's why I use usize, and it's fine. Like you can use int from pointer and pointer from int with usize, and it will also work fine with WebAssembly. So before this project, I made an Rust WebAssembly project, and there, yeah, you have to use unsafe and stuff like this. So I added Rust equivalent stuff there. Maybe that would be helpful. Another thing is, yeah, all the examples use null terminated string. Maybe there are some other example, but there's a trick that we can, with that trick, we can pass regular strings from Java to Zig, Zig to Java, and I will also mention that it's in the code. So here, uh, this is a very simple function which gets pointer, the address in the memory, and length of that string. So then we get this pointer and convert that to slice. Then yeah, basically we just change the first byte here to age. Here's a struct, and here we get a string. So you can think of this as a string because it's pointer and length. With WebAssembly, you can get multiple arguments in the function, but you can only return one integer back. Let's say it that way. So this basically uses the standard JSON package to parse it and return the pointer back. So what it achieves is it creates this struct and returns that back. Yeah, the thing that made me confused was that when you create a struct in regular way, it creates that in stack. But you need to use allocator create to create that on the heap, because the lifetime of this struct is not like, it's not ending here, it's not returned back to any other zig function. So that was an important point. Like when you create it this way, it's created on the heap, the pointer is also on the heap. Then yeah, you can use this to set the result and return back. So in the Rust, it was like boxing, and that enabled it to move the variable to the heap. But here it's more explicit. You use allocator if you need heap. Okay, and yeah, you can basically return something like this, and you can also return the pointer like this. And you can work with it either way inside Zig as well. That's very useful in your tests. We also have a test example. And yeah, basically we reuse the struct we created in Zig that lives in Zig, but that's not freed after this function returns. So the host Java can use that struct by giving its memory address. So why? Because maybe in this example, it's very a small object. It's not expensive to parse it again and again, but you might need to reuse that struct to make it more simple, or maybe it's expensive to create and calculate the struct, and you are going to reuse, like you will give new data to that struct with some function, and it will calculate something. And yeah, here we reuse that struct, and we create a new string. And to give an example of passing string back to Java or any host language, so we just write the book, because this is parsed, we get value and then the field book, and write it to the string. And yeah, basically we turn that to own slice and catch. You need to use this catch and panic, because you can't use error signature in the functions that are exported to WebAssembly, basically. And yeah, this is the trick. So we can't return multiple values, right? If we could just return the pointer of the string and the length of it, that would be great. So we can't return two values. But what we can do is, since we know this function, we can like define an interface. Like this function is going to return a pointer to an array, so the size is known beforehand. So there are two values. One is the pointer to the string, and another is length of the string. So this is the trick that make it work without null. What was the correct name? Yeah, null terminated string. So there's also like you can also use array list, but I added alternatives that might be helpful to understand for Zig newbies like me, but I think this is better. So the Rust equivalent, just compare, and maybe you are coming from Rust, so it might help. So here we also create a vector of two values and return that basically. Okay, this is the test part. The test part is important or useful for two reasons. One is you can see how you can use these functions inside Zig, like with pointer cast, pointer from int cast, stuff like that. And also how to free the memory. This was also very new for me, but yeah, basically when you are using standard testing allocator, it also tells you if you are leaking memory, and there are functions that use basically this allocator is inside this file. So the functions don't get allocator from Java side. It's implicitly using the same allocator. So I had to shadow it like this. So that, for example, this one is using the explicit allocator, but the other functions are also using that. So they will also use the same allocator for testing. Yeah, so we can also check the Java side. Yeah, what happens here is we define we read the WebAssembly bytecode file and we define our functions inside Java. And then, yeah, the first example is cello word. So with this cello word, we allocate it on the zig side. Zig side gives us back an pointer to the start of the memory, and then we write to that memory, and then we call edit string buffer function. It will just change the first character to H, and we will get hello world. So we write this to this buffer, and we read it from the same place, because we know all the we know the start and length beforehand. The this edit string buffer function returns void, so we can just read from the same place. This is to give a simple example, and then we parse the JSON to get book code struct pointer. Yeah, first we need to pass the JSON string to the Zig side, and yeah, basically we give the length to the allocator function and then get back the starting position. We also know the length of the JSON because we have it in the Java side. So using those two, we just write to the position in the WebAssembly memory. We write to the position Zig returns to return to us. Then we call the function with start and length. So it's just like giving a string uh, to this function. But first we need to write it to the shared WebAssembly memory and give the starting position and length. Okay, now that we have the book code struct pointer uh, in the Java side, so we have a reference to a zig struct. When we call get book name, we can reuse this struct pointer, and the trick we used was an array of length 2. So this function returns position, the memory position to that array. We know that it will write U size like U32, so it's 4 bytes for 1 and 8 bytes for 2. We read this from the memory, and this was like little endian stuff like that. So basically we get the first integer and second integer. First one is the start of the string, second one is the length. Then we use this information to read from the shared WebAssembly buffer, and then we can print. So it will give it like this. So this is JSON. So we get the book. So we will get Madonna in a furcat. And when you run the Java example like this, it will get the string in Java. This is a simple contrived example, but it shows you can pass string from Java to Zig, Zig to Java, and you can reuse the structs inside Zig. So maybe we can also just quickly discuss about the memory model. So we have this WebAssembly memory, and basically everything lives inside JVM, but let's think about this way. There's Zig and Java. So Java calls Zig to allocate memory here. So it gives the length. So this is the length, and the starting position is this, and it gives back the starting position to Java pointer. So why do we allocate on the guest language? Because Java can already access here, right? Java can access, but you want the guest language to know what's going on, to do calculation, or basically do the accounting of memory on its own side. It will be the case for C and other languages as well. So this is why we allocate on the guest language. And what's happening with our string trick is that it writes a string like this, and then it writes like 4 bytes, 4 bytes. It writes this another array, and it returns the starting position of this to Java. So Zig, Java, and then Java basically reads this. It knows that it has length of 2, and from the value here, first value is start of the string itself, and the second value will be the length of it. So Java can read the string. And maybe another thing is that for structs, if we use allocator create struct, then it will just create it on the heap directly. If we just create the struct like var string something struct, it's in the stack, and that basically means when the function returns, it's going to be removed. So it's fine in regular zig programs, but here we want the object or struct to outlive that function, and basically we want to manage the lifetime of that struct from Java side, maybe. So it needs to outlive. So this is an important point if you want to give a reference back to the host language. So that's all, and thank you for listening. I'd like to use this opportunity to share Zig Turkey or Türkiye, new name, Discord server. I will put the invite to the description, and I would like to meet anyone who is in Turkey or who plans to visit Turkey and interested in talking Zig together to join. Yeah, everyone is welcome, and thank you for listening. And Zig community is great so far. Thank you again for Travis for your help. I hope the community stays this way. And Andrew's personality, jokes, and smiling face also was a big factor for me to try Zig. So maybe that's an effect on why Zig community is great so far. Thanks.